All right, let us try another question. And I will read it and I will encourage you to write it. You will see it, the question in the corner on the video. So please take heed to write this question. The question says, a helicopter sets out from its base P and flies on a bearing of 123 degrees to point Q, where it changes course to 60 degrees and flies 18 kilometers to point R. When the helicopter is at point R, it is 22 km from the starting point. A. Find the size of angle PQR. Calculate the bearing on which the helicopter must fly to return directly to the base, and C. The distance QR. So what you could do is pause the video to ensure that you have the question copied, and then we will continue. Now that you have that question copied, let's begin. Now, let's see the information that is given. The information that is given. The first information given is that the helicopter sets out from the base P and flies on a bearing of 123 degrees to a point Q, right? So let us begin by drawing our north line. Remember, to do this, we can draw the north line. And if you think you can do the diagram by yourself, pause the video and see if you can sketch the diagram and compare to what we will have. So let's begin. So let us begin drawing. So it says the helicopter sets out from the point P. Sets out from the point P. So the first thing we'll do is draw our north line. We have our north line. And the starting point is the point P. So it sets out from the point P. This is our north line. So we indicate that. And it flies to the point Q on a bearing of 123 degrees. So from P, it sets out on a bearing of 123 degrees, right? 123 degrees to the point Q. So at Q, this angle here is 123 degrees. All right? Now, let's just darken it. That's our point Q. Now, it says from Q, it changes bearing of 60 degrees. It changes direction on a bearing of 60 degrees. So here it is, the helicopter starts from its point here, flies to Q, and from this point it changes on a bearing of 60 degrees. So whenever we are drawing a bearing, the first thing we must remember that we must do is draw our north line. So from Q we will draw a north line. And it says it goes 60 degrees. Right, so the bearing of 60 degrees. Remember, every bearing must be measured from a north line. So here we have 60 degrees. So it travels on that bearing of 60 degrees to the point R. So here we have the point R. Now, the question goes on to say that the distance from Q to R is 18 km. So the distance from Q to R is 18 km. So we write that in. Now, it says when the helicopter is at point R, it is 22 km from the starting point. So the distance from its starting point to R is 22 km. So we're going to draw that line, and indicate our 22 kilometers. So our diagram should look like this, right? Our diagram should look like this. P to Q, 123 degrees. Q to R, on a bearing of 60 degrees. The distance of PQ of QR is 18 km, and the distance PR is 22 km. All right? So that is what your diagram should look like. And if you have that diagram, you can give yourself a tap on the back. That was well done. So let us now answer the questions that were asked. And the first question asked is calculate the angle PQR. So we have to calculate the angle PQR. So when we're doing this, the first thing we need to do is identify the angle PQR. So PQR would be this entire angle here. Well, from what is given, we know that here we have 60 degrees. So PQR is the sum of this and this. So if here is 60, how do we find here? Now notice, remember, we said that when two lines are parallel and we have a transversal line, the sum of these two angles here, the sum of these two interior angles here will give us 180. They are supplementary. So this angle plus this angle will give us 180. So to find our angle here, we will have 180 degrees minus 123 degrees, which will give us 57 degrees. So our angle here is 57 degrees. So therefore PQR is equal to the 57 degrees plus 60 degrees, 117 degrees. So the angle there gives us 117 degrees. The next part says, calculate the bearing on which the helicopter must fly to return to its base. Calculate the bearing the helicopter must fly to return to its base. So what it is we're talking about here? What is it the question is asking? So the helicopter, this is the base. This is where it starts. It then travels from point P to point Q on the bearing of 123. It then goes on a bearing of 60 degrees from point Q to point R. And the question is asking, what bearing must the helicopter fly to return to its base? So what we're asking, what the question is asking us to find, and let's identify what it's asking us to find. It is asking us to find the bearing. We have our north line from here around here. We're asking to find this angle there. All right? So, how do we go about finding that angle? How do we go about finding that angle? What it is given? What is given to help us to find that angle? Note that here we have 60 degrees. Now, using our knowledge of angles, parallel lines, what we could do is extend this angle a little. Extend this line, a little. And what we know is that here we have a straight line. And a straight line will always be 180 degrees. So on this portion, we have 180 degrees. All right? Now, notice, now we have what is called a Z angle, or an alternate angle. Now, if here is 60 degrees, it means this portion between here is also 60 degrees. So far, we have 180 degrees from here to this point. All right? Now, from here to here, between here, because it is a Z angle, is formed, an alternate angle is formed. If here is 60, there will be 62. So all we need to find is this portion between here. And we will get the bearing on which the helicopter must fly to return to its base. So how will we find that bearing there? Now, or how will we find this angle here? Now what we have? We have this side, and the angle opposite. The angle opposite there is 117. We're given a side. Now, if we find the angle opposite this side here, remember, this entire angle here, the bearing here is 123. So if we could find this portion between here, we will have two sides or two angles in the triangle, and then all we do is add and subtract from 180 to find the angle that we need. So let me go that again. Now notice we need this angle here. We know that here is 180 since it's a straight line. We know that here is 60 since it's an alternate angle, and alternate angles are equal. Now if we can find our angle here, if we could find that angle there, we will be able to add the 180, the 60, and that to find the bearing of P from R. So how do we do that? What do we have? We have this angle, the side opposite. All right? We have this side, and we can find the angle opposite that side. And then using the sum of the angles in a triangle, we add up the two sides, add up the two angles, and subtract from 180, we will find the angle between there. So let's do that. So we know we're given that PQR is 117. We found that. So sine 170 over 22 sine 117 over 22 is equal to sine, that's what we need here. Let's call that sine P over 18, the side opposite the angle. So let us transpose and calculate. So we carry that over here. We have 18 times sine 117 over 22 is equal sine P. All right, sine P. So when we would have done that, and calculated it, what we will have is 0.729 is equal to sine P. So calculating this, our answer will be 0.729. Now, so to find our angle P, P is equal to sine inverse of 0.729. So check your calculator and see what is the inverse. Remember to ensure that that calculator is given in degrees, right? Or the calculator is in the degree function and not the radian. Now, the sine inverse of that, sine inverse of 0.729 will give us the angle P is 46.8. So this angle between here, this angle here, the angle here is 46.8. So how do we find that angle there? We add this entire angle here plus this, and subtract from 180. So the angle here, angle at R, the angle at R, let's call that QRP. The angle QRP will be 180. Take 117 plus 46.8, which will give us, 180 minus 47, that will be 63.8, 163.8. And subtracting that, we were left with 16.2 degrees. So the angle between here is 16.2 degrees. So what is our bearing of P? From R, we find the sum of these three. The bearing of P from R is equal to, and we add 180, which we have here, plus the 60, that portion between here, plus the 16.2. And our final answer will be 256.2 degrees. So the bearing of P from R is given as 256.2 degrees. Okay, and we will now find the distance of PQ. We now find the distance of PQ. All right, so what you can do, if you think you know how to do it, and I know you know how to do it, using either the sine rule or the cosine rule, use the information to find that distance PQ. Now, to find that distance PQ, we could use, we have two sides, and we know the angle between those two sides. We could use our cosine rule formula, or if we have a side and an angle, and we know this angle, to find the side opposite that angle, we could use the sine rule formula. So we could either use the sine rule or the cosine rule formula to get our answer. In this case, we will try both and see if we have the same answer, if we get our same answer. So let's try it. Now, reminding us of our cosine rule, let's start with the cosine rule, that if we want to find PQ, PQ squared is equal to, using our two given sides, if we want to find the side, using our two given sides will be 18 squared plus 22 squared minus 2 times 18 times 22. And the side that is opposite PQ cos 16.2. All right, so we have our formula there. We using the formula, right? So we can simplify now. Having 18 squared will give us 324 plus 22 squared will give us 484 minus 2 times 18 times 22 cos times cos 16.2, 760.553. All right, simplifying that, adding then subtracting, we will now have 47.447. So PQ squared is equal to 47.447. So PQ will be equal to the square root of 47.447, giving us 6.89 km. All right, so we use the cosine rule formula to show you that our distance PQ is 6.89 km. Now, let's ensure that we can check it now using our sine rule to see if we have our same answer. Now, we can use a given side. Now, we could either use 18 and 46.8 or 22 and the 117 that we have there. Now, I will use sine. Since we have to find a side, we will put the side at the top. 22 over sine 117 is equal to the side that we need, PQ over sine 16.2. All right, so we just double checking to see that we'll get the same answer. So transposing, we now have 22 times sine 16.2 over sine 117 is equal to PQ. And when we work that out, we will find that our answer will be 6.89 km. The same as our answer here. All right, so you could either use the cosine rule or the sine rule, we will get the same answer. Now, what I will encourage you to do is go to your worksheet and do some more practice questions based on this. And if you didn't get it, go back and check, or you can look the videos over of how we found the side, how we find the angles, how we found the bearings, and review it. Look it over until you get it and go back and you will try it. And I will encourage you that don't give up, don't get frustrated, keep working, keep practicing, and you will get better at it. All right, but in our next topic we'll look at is will be angles of elevation and angles of depression.